Thank you, Wesley. Very kind words, appreciate that. Welcome to the presentation tonight. It's a real honor to be here and to be able to present a product that I've near and dear to my heart. It's kind of, I feel like that it has maybe a funny title, Urethane Board, Oh the Possibilities, but I'll go into why I chose that as kind of my byline. But I'm going to start first with how we even got here in the first place. I'm the sales manager at Coastal Enterprises. We're the manufacturer of urethane board located over in the city of Orange, just across the way from the Anaheim Stadium and the transportation terminal over off the 57 freeway. But it all started back many years ago with our founder, Chuck Miller, who was working for NASA in the Saturn program back in the 60s. And how he got involved with the urethane board was NASA had a problem. They wanted to get this rocket ship to the moon, and they had to be able to keep the temperature of the fuels at the correct temperature. The first stage rocket down here was a combination of RP1, which is a rocket grade kerosene. Stage 2 and 3 was liquid oxygen and hydrogen. And what they were having problems with was they would pump it into the tank. They couldn't get to hold the temperatures correct so that the combination of the blend worked. They discovered that there was a material that was invented back in the 30s, late 30s, early 40s, called urethane. Had great insulation properties. They tried it out. They were able to line the tanks, and the rest is history, so they say. But his passion was the urethane board, and so he started his own company. He started producing this, and as he progressed, he was successful with the product, and he wanted to give back to the community. So when we make our product, we might have what you call remnants or leftovers or sheets that aren't usable or sellable. So we just, instead of filling up the landfills, he wanted to give back, so he started a school donation program. My coworker, Crystal Rhodes, she couldn't be here tonight, but she's in charge of that. I think Wesley and some of the other professors have had contact with her. But we will donate the material to the school to use in the classes and some of the projects. And so what is it? By definition, it's a rigid closed-cell polyurethane foam used for various applications. It's pretty boring, but the thing that kind of got me where I wanted to go with this presentation was right here, applications. This product is very humble in its presentation. That's what the product looks like. It's large blocks, and you look at it and go, well, what can you do with that? Well, one of the things is you can take it. And these came from your sculpturing department. And talking to Matisse, he was saying how you do a lot of hand carving, that sort of thing. These are prime examples. This is one of the students from Cal State Long Beach. Additional piece of finished product work in process. This was by one of the professors, I believe. This is called Sun and Moon. Again, made with the product. Devin Wilson produced this. It's called Doomsday, I believe, Doomsday 2024. This was by another student. I'm not sure, I don't have any notes or didn't get any information on where this was presented. But again, this is based and used out of those powder pink rose-colored blocks that you saw earlier. This was a student project. I didn't have any more information. Again, I got these kind of late, but I did want to show some of the projects and things that were generated by the school and by the students. Assuming they might have been on the campus somewhere at one point in time. And then Brian Crockett, he's the sculpture professor. I wanted to show these because this is called Exomorph, and what he did is he used the molds, and this is going to tie into the industrial side of things later on. What he did is he used the precision board, or the urethane board, and carved out, these frogs are like 3 feet. So he carved out the frog, cast a mold on the frog, then recast with the resin and materials and waste materials that were found in the Seine River in Paris for this one, and the LA River for this one. I bring that to the point because this is the same kind of a process of taking a mold, making a master, casting off of that, then reproducing off of the step-by-step process. But again, what is it? This is where I want to go with this. I'm quoting myself here. I don't think that's probably not too cool. But anyway, it's one of the most versatile, underappreciated materials available for use in the design and manufacturing that so many people seem to know so little about. And my hope today is to present, I'm going to present a lot of information, and sometimes I'm going to get deep into the grass with the details. But my whole plan was to present all this information that I've gathered over the years I've been in the plastics industry. And the hope from that is that at some point in time in the future, when you're out you're working your jobs or you're working on projects or whatever it may be, I'm hoping that you'll say, oh, I remember seeing something about that in that presentation back in March. So with that said, I'll start with the densities. This product is a thermoset resin, which means that it's a two-part A and B mixture. It comes in liquid form, and to make a solid part, you take the two, combine them together, they go through a mixing head, and then they're poured into a mold. They exotherm, and then they solidify, and you get the blocks like you saw in the previous slide. What we do with my company, we have multiple densities. Again, I'm talking with Matisse. He said that 15, 20 pound is kind of the go-to material for hand carving. As you can see, we go from the lightest 4-pound density up to a 75-pound density. And to kind of show you a little bit of the variance in between, I've got all these densities over here on the table for you to take a look at some point in time after the show, after the presentation. But here's our 4-pound. 4-pound PCF, pounds per cubic foot. You can see it's pretty light, not too much body to it. Our heaviest material is our 75 pounds per cubic foot. You can hear the difference. It's almost like a solid brick. And each one of these has its own little niche of what it works best for. The go-to material, 15, kind of right in the middle. It's great for hand carving. 20 pound, same thing. So how do we make this, or how do you get the different densities from this? Again, you take a two-part mixture, put them together. It's like baking a cake. You put them together, once you bake them, it turns into the solid block. You can't grind it up, you can't reuse it. It's not like a thermoplastic resin where you can regrind and remold and that sort of thing. But how do we get the different densities? It's in the recipe. And the difference between the two, or the densities, is in the cell structure. This 4-pound density, you can see this is a closed-celled structure, which means it has no absorption. The only open cells on the entire blocks would be the surface of the block itself. And that's because we cut it, and the saw curve will open up some microscopic cells across the surface of the part. The difference between a 4-pound and higher up is the wall thickness. You can see the walls are thinner. As you go up in density, you're still getting the closed cells, but you're getting thicker walls, and then you get up to like the 60-pound density, and the walls are even thicker. And that's how we get the densities to increase from the 4-pound with 16 densities going up to the 75. Now, the differences is the higher the density, first of all, the thicker the wall section, the stronger and smoother the surface. If you need something that has a very smooth surface, you're going to want to use a higher density because the cells on the surface are going to be smaller. You can fill them, prime them, paint them, and you're going to get a nice mirror finish. And the higher you go, the better and smoother, the stronger and smoother. The problem with that is it's heavier, so if weight's a consideration, it's going to be much heavier to deal with, and it's more expensive. For example, it's pretty much weight related. The 30-pound density in the middle is half the price of a 60-pound. The 15-pound density over here is half the price of a 30. So these are some of the considerations and factors you have to keep in mind when you're building projects or looking which material you might want to use. Also, there's two formulations, a low temperature and a high temperature. The difference is the low temperature is is designed to have processing temperatures or working temperatures of continuous use up to 200 degrees Fahrenheit. The high temp, continuous working processing temperatures up to 300 degrees. And I'll go a little bit later in and you'll see why you need the difference between the two. There is a price variance. The higher temp, again, is going to cost more. It's going to be about 25% higher than the lower temp. But in a lot of cases, the low temp will work. For example, I had a customer in Arizona call and said they wanted to build a sign and use high temp material. I questioned, why do you want to use such an expensive material? Well, it's really hot over in Arizona. Yes, it's true, but it's never going to be over 200 degrees continuous use. So convinced the client to use the LT. Project turned out great and all went well. Another strange thing about this product is what's it called? It depends on the industry you're in. This product seems to have more names for the same exact product, tomato. If it depends on what industry you're in. If you're in industrial uses, you're going to hear urethane board, tooling board, carbon fiber board, that sort of thing. But if you're in the architectural design, sculpting, modeling, that sort of thing, the most commonly used acronym is HDU, which is high density urethane. Familiar with that term, HDU? Heard of it? No? Well, if you're in this arena, that's probably what you're going to hear most of. But then again, the problem is you have people in the industry, industrial uses, still using some of the terms over here, and you still have the design over here using the terms over here. So it's one of those where you've just got to be around it enough to know when you hear one of these terms, you know that's what they're talking about. So. Okay, so what industries are they used in? Four of the big hitters are aerospace, automotive, signage, and marine. Also included prototyping, theming, architecture, and within each of these, there's a multitude of different applications that can be used within that industry for that process. A lot of times, the product itself is the end product. A lot of times, it's 2 or 3 steps removed from the end product. So the manufacturing processes most used are CNC, water jet, laser, sandblasting, and hand carved. The first one I'm going to go with is the CNC. One of the main, again, the questions most asked about this product because so many people know so little about it is, can I machine it? Is it volatile? Am I going to have to wear safety gear? This is a material that does not outgas, has no volatiles. The product, if you want to wear a mask, if you want to wear a mask, you can wear a mask, but you don't need to because it's not going to cause any adverse effects. The dust and particulates from cutting the HDU board is not any more or less harmful than cutting a piece of pine wood with a saw and the sawdust. It's very inert and very user-friendly as far as safety and that sort of thing. I wanted to show this area here too because if you are into an area where you're using a CNC machine, you can use any kind of a tool or a bit for this product that you could for a wood project of anything. When they cut, people will call and say, I'm getting a lot of powder, I'm getting a lot of dust. First thing you know with the response is with CNC, it's all about the feeds and speeds. They're just going too slow. These high-speed cutters are meant to cut and cut fast, and if they're getting powder, what's happening is they're going too slow, and instead of cutting chips, they're pulverizing the material. They're still getting cuts, they're still getting the areas machined out, but they're losing time, and they're just making a mess. So another CNC, these are a little bit more sophisticated. The thing about this is you can see the depth. You can get longer bits, longer drill tools, and nest these together to get the most maximum efficiency with the least amount of scrap and remnants. And just another example of that. Another application is the water jet. Water jet system, I have some samples. Well, thanks to WarJet, they provided these drawings and samples, but what this is our product, the HDU board, and to cut it, they're using a water stream that's loaded with an abrasive, and then it's placed over the material and turned on and shooting at 60 to 90,000 psi. So it can cut through aluminum, and it sure can cut through this. The good thing with this is it's very precise, but it has a little bit of a drawback that if you get too thick, you'll get what they call trumpeting, where the stream will be coming down, and then as it gets deeper and deeper, it starts to flare out at the bottom. So you get a little bit of a flare and lose a bit of the tight tolerances or the dimensions that you're looking for or trying to achieve. This is another example of the water jet. This was a sample that's over on the table over here if you want to take a look at that later. You'll notice one thing on this too is that the color is not the kind of the pinkish color. This material is affected by UV, and if it's exposed to the sunlight for a period of time or just out in the open, untreated, without a primer or a coating or anything like that, it is going to get this kind of a yellowish tint to it. It does not really harm the product. You can take some sandpaper or something and not grind it. It wouldn't be necessary. You could sand it down, get back to the base material, and still have a good piece of product to use. Again, this is a sample. It's over on the table as well. I brought it to show that in the area right in here, that the trumpeting, because of the thickness, if you measure it across the top, and then you measure the same area across the bottom, you would see a variance. It would be expanding a little bit, and again, due to just the nature of the beast and the process that water jetting is. Okay, laser etching. For reference, we have a penny. We can see we can go small. I put engraving, etching, and cutting. I almost didn't put cutting because of the following. For engraving and etching, it does a great job because you're only going slightly deep. But when you start cutting, what happens, the thicker the material, it starts burning. And you can see right here and right there, you get a little bit of a burn on the side of the product. And that's just the nature of the laser cutting, going too deep, trying to cut too thick of a piece. But for surface etching, things like that, I've got a couple of examples, again, over on the table. One from Boss Laser, and don't remember who made that one for us, but there are a couple of samples over there. But again, the etching and the engraving, spot on. Cutting, not so much. This was courtesy of Ken Laser Engineering out of Minnesota. You can see, because of the industry, this was a Jaguar they did for us, and they're calling it HDU because of the industry that they're in. So again, the detail on this, I couldn't bring this one, but it's a nice piece. It's a very nice piece. This one, I will say I'm not that familiar with the sandblasting portion of it, only because doesn't come across my desk that often. It is a process, and if you're ever down in Corona del Mar area, there's a place called Rogers Garden, and it's a nursery and garden area. This was a sandblasted sign. The one thing that you do have to do with this is you do a lot of masking off, and when you're sandblasting, but it's outdoors because it doesn't absorb anything. This sign has been around, I know, since '79, and I know that because that's when I moved to California, and this is one of the first places I went to. So it's been around, and actually our company, if you treat this sign with some tender loving care, we will provide a life of the sign warranty, which means if you will clean it, paint it, keep it up, keep the upkeep, we'll give it a warranty for, life of the sign. So then hand carving, which again, talking to Matisse, there's a lot of hand carving done in this. This one we're going to come back to because this is, to me, an impressive piece. But this again, the go-to material for this is 15 pound, 20 pound. Get any higher than that, it starts getting a little tough to cut. Anything below a 15, you start losing the ability to hold a profile and hold an edge. It's not dense enough. It just won't. You can cut an edge, but you're not going to be able to hold it. You'll roll the edges, and it won't stay crisp and clean. Okay, into the signage. This is, again, a CNC. They're machining this sign for this insurance company. What I wanted to show here is the mounting of this thing. This material is not structural, which means it will bend, it will flex, and you can't screw and tap into it. So what you need to do is, if you're going to hang a sign like this, right up in here and here, what was done was you drill a pilot hole, you put in some hardware, you epoxy it in, and then that's going to hold the sign. You'll be able to mount it. And the same, this is probably not the same thing. This is clad because it's not structural. That's got a metal frame inside, and it's clad in the HDU board. And then, but you can get the wood texture and all those features. Again, life of the sign warranty on this, as long as it's not mistreated and taken care of. Dimensional signage, 18-pound density. If I wanted to show some other just examples, this eagle is backlit, so that's one of the options you have with that, and it's in Norwood Fire Company. If you'd like to see it, it's in Pennsylvania. So if you make a trip back there. For the bakery sign, I wanted to show how big this was, and I thought, well, that picture doesn't really show that. So I went and I found out this is over in East St. Louis. And again, the center part is all the HDU board with some framework on the inside. Of course, the poles on the outside are clad. And again, there's signs that are much larger. You can go much larger with things like this, but it's just a representative sample. This one had twofold. I wanted to show the outdoor use, again, because it's closed-celled structure. The weather is not really going to impact it. It's not going to absorb water and freeze and expand and deteriorate. But then when I saw the picture, I just thought, this is a beautiful sight. Now, if you would like to see this is over in Yellowstone. It was built. The sign was made by a company in Wisconsin, and if you do go there and you do see it, the website says, be careful, this area is frequented by grizzly bears. So just, again, mainly to show you that the weather is very, it holds up very well in weather conditions. Okay, modeling. Talked about this with some of the professors earlier. This is a full-scale model of a BMW, or it will be. Or it was. It started out where the bonded parts or the pieces are in the general shape, near net shape. Then you've got the giant five-axis CNC machine, whittling it down, carving it down to the bottom left, getting closer over here on the left. But one of the things that you have to make sure of when you're modeling, you have to have the right tool for the right cut. So you can see this is using his high-precision chainsaw for making some of the cuts. But then it gets closer, and finally, after several weeks, several months, this is what the end use looked like. Full-scale model of this auto. Casting. This is one of my favorites, I think, because again, there's several steps in between going from this to the finished product. This is a medallion, a plaque, it's going to be a bronze plaque for the city of Tacoma, Washington, for their police department. It's initial cuts. You can see on the, you can see the rough cutting here. You're going back over it with a finer cutter to smooth it out, to get it closer to the finished product shape and size. A little bit more detail here. So you can see from step 1 to 2 to 3, this is the lettering that they've carved into that. But to get from this to the bronze casting here, there's a step that has to take place. And what it is you take this mold and you pack it with ceramic. And so after you've packed it with ceramic, you've made it basically a mold. You take all the precision board, the material out, and then you're, polish it up and get it ready, and then you're able to pour and make a bronze casting like this. It's still not ready because you've got flash around the outside perimeter. You still got some polishing to do. But once it's ready and they've treated it and painted it, it turns into a nice piece, which was presented to Tacoma Police Department. The next one, just to show a bit of scale, half of a class ring. The size of this is an 8-pound density, and one of the main reasons it's 8-pound because this thing is massive. And as I said earlier, it doesn't quite hold the edge, but the same process was happening here. They took this piece, packed it, made a ceramic tool, did the other side, and if you want to see it, it's at the Texas A&M. That's their, it's in their one of their entryways into one of their facilities. Total weight of this thing is 6,500 pounds. I think they have 2 more in process. I'm not for sure, but to me, a very impressive site as far as just the size, scope, and scale of this piece. Architectural and design. This is a 30-pound density, and the reason it's a 30-pound density is, as you can see, these pieces were cut prior, and then they were assembled in this kind of a pattern. When you're doing something of that size and having to mount it to the ceiling, that sort of thing, you need a little bit more rigidity. So that's why they went up in the density to a 30-pound. And again, I'm not sure how they mounted to the ceilings, but again, it was not just glued or anything like that. You're going to use hardware that's going to hold and keep it held in place. Another piece of ceiling accents. This is in New York City, and what they did is the American Girl dolls. Anybody familiar with American Girl dolls? Good. This is mainly their showcase store. It's on 75 Rockefeller Plaza, right in the heart of Manhattan. And these pieces were cut, then assembled. And the main thing here, which is keep in mind when people are needing projects, the fire codes in Manhattan Island are tremendously stringent. This passed flying colors. It's in there. It's in process. And another place you can find product that it has to meet fire codes is in Las Vegas. Next time you're all in Las Vegas, or if you go to Las Vegas, you'll see a lot of products, a lot of facades on some of the casinos. Go up and do the tap test, and you can tell it's not concrete, it's not stucco, it's probably a coated urethane board. This is kind of a before and after picture, but it's mostly after. This was, the density is a 34-pound. Again, they went up in density only because they wanted the detail. This is a faux stone wall facade. And you can see with the CNC cutter is just programmed to cut out the stone shapes. And then the artists will go in and coat it, brush it, paint it, and it looks like it's from a distance or even up close, it'll look just like a stone wall. Okay, back to this. This is one of our customers that he does hand carving, and I was really impressed with this finished product. This is the gentleman, his name is Brett Steves, and this is the wall hanging that he generated. So you can see this was the little slide that we just saw, and then he put together the rest of it, treated it, and it was installed. I don't know where it was installed because it's a private home, but a very impressive piece, and just shows the options and the viable projects that are out there using this. I don't know what other material you might use for that. Anybody, what might be a good, I don't know. But anyway, this was the precision board is the product to use, and that's what was used here in the 34-pound density. Okay, on the construction side of things, you can see the height and size of these panels. These are composite building facades, and which means they used the precision board to make a tool, and then they laid up these facades over the top of them cured, and then installed them. And you can, I don't know if you can see the detail, but there's just multiple lined up across the face of this building. So, and the scale of things, you can see this is the gentleman at the base. Another application that you can probably see maybe on your way home tonight if you're driving the freeway, these concrete form liners, they're used for making a mold to what are these configurations. I know down in Orange County along the 5, just past down south of the 55 freeway, there's a lot, the sidewalls on those freeways are covered with these form liners, and it's a very high use material because they can only get so many pores and so many molds off of the master molds when they are making these. And so it's a lot of repeat business, using 15-pound because it's just a good middle of the road, holds a decent edge, holds a good profile, and it's and used extensively for that product. On to tooling, thermoforming, vacuum forming, drape forming, and autoclave. To me, the thermoforming and vacuum forming, they're very close. I mean, there is a difference, but basically you're taking a mold two ways. You can take a male mold and heat up a sheet of plastic, pull it down over the top. You can see in this case, these side panels all come down to clamp around the perimeter of that sheet. Then vacuum is drawn. The other way to do this too is the reverse, which is this is thermoforming as well. This is the car seats. You can see that this configuration kind of conforms with that, with the car seat. Again, plastic material drawn down over these molds to generate the parts for the interior of the car seats. Then with vacuum forming, though, it's a different process because, well, the other process is concave mold, whereas the sheet is laid over the top, and then a vacuum is pulled, and the material is drawn down into the mold. And it kind of depends on what you're looking for. Which piece, what side of the piece has to have the prettiest aesthetics. That's kind of what's going to determine which way you go with the either pulled over a male mold or pulled into the female mold. Now for this is the steps that it took. The top left is the initial block of material carved down to a near net shape. Then the middle section is some smoother roughing, and then over here on the right you'll see the very smooth finish, mirror finish, and you can actually see the vacuum holes. And what this was used for was to pull polycarbonate face shields and protective face shields over it. And you can see the shape and configuration, how they were pulled and drawn. So again, vacuum forming, here we go, the 48-pound HT, you'll see that. The reason we're using HT is because when you heat up a polycarbonate sheet, it has a very higher temperature to get it to be ready to be molded and pulled. So it's going to be higher than 200 degrees. So the sheet coming down on top of this could be as high as maybe 350 degrees, but it's only for a short time, because once it's pulled down, it starts dissipating the heat and it drops below 300 quickly. So the HT is used for vacuum forming, thermoforming, anything where the heat is going to be above the 200 degrees Fahrenheit for the LT material. For drape forming, you can see the size of this tool and what this tool was used for. Drape forming, again, is used a lot for very large, much larger pieces of product that's needed. What this was used for was for this observatory. The shutters on the observatory needed a protective skin, so they drape formed plastic sheets to cover those shutters. So multiple sheets were drawn off of this and covering these shutters at this observatory. So again, the scale of things and the applications, the possibilities, very broad and wide range. Autoclave, this is a process where this mold is again high temp, 40-pound density. The part was laid up with a carbon fiber. The green is a vacuum bag, which pulls the vacuum onto the part to keep the part in place and draw out all the air. Then it's placed in this autoclave. We know because of the temperature range that this autoclave doesn't go above 300 degrees or hovers around 300 degrees. But what also happens in here is they fill this chamber with pressure, and that helps again pack the carbon fibers to get a part that has zero air and total full compression. Masters, molds, and plugs. This is another example of the same word for, people use these three words for the same process or same part. This was for the aircraft, and the project started with this drawing. I don't know if you can see, but there's some lines cut like this, and so this is what they wanted it to end up with. So instead of making just a rectangle and then carving it out, we took this to a near net shape. Took it to the customer. They machined the final parts, which are these, and they made a mold so that they could make these parts. But then they duplicated, or they used a double purpose. They took that same mold and they made a couple of fixtures, check fixtures, and work fixtures. So what they did is after they made the molds for the parts and they made the parts, then they made it so they could actually check it for dimensional dimensions, and also for a workstation where they could actually put it together, and it ended up on this aircraft. This is I wanted to show this again on scale of size of things. This is a bonded block where there's a whole bunch of pieces bonded together. You can see the scale with the forklift. This was for a military project, and when we asked if we could take some pictures of the final mold, they said no, absolutely not. But they did say that we could take a picture of this. Doesn't really tell you much, but that is the fixture that was used to help produce this, the cockpit cover. And again, this is a double application where they used the tool here as a cooling fixture. So when they're making the canopy cover, they used it for a cooling fixture, and then after that, then they also used it for a check and trim fixture. So again, multitasking with the tools and with the product. Again, we have a customer that uses the 48-pound density, and what they do is they make masters, and the master is used similar to the frog example earlier. They make a master, and then they will cast a mold off of that, and then they will produce the parts in that mold. So the master goes up on the shelf until the mold serves its purpose or wears out, and then they'll pull the master back down, make another mold, and keep doing that. But they also make check and trim fixtures where they'll take the master and make additional parts so that when the parts come out of the original molds, they can put them on for checking them dimensionally and trimming them to the right configuration. Now, the customer that's using this is based out of Vermont, and it's called Beta Technologies. It's, the acronym eVTOL, electric, vertical takeoff and landing. This is one of the leading companies in the country for electric airplanes. And this shot is the first test flight over Utah that was extremely successful, so successful that UPS is building a fleet of electric eVTOL aircraft. And right now they have 10 on order and 150 pending. So, and that's just with UPS. So, a market that's growing very well, and Beta Technologies is one of the leaders. Okay, theming. Had a little trouble when I was putting this together, only because we all know we have a multitude of theme parks in the area, and they're very conscious about their IP. So instead of using any of that, I went to the Mall of our pictures with Mall of America back in Minnesota. This is the train, and it's the Moose Mountain attraction. So this is clad and built and made with the 30-pound density precision board. You can see the detail you can get, the rivets, the steps, all that. Again, structurally, these stairs, can't climb on them, but again, they represent the train and the materials, and it can be modified to just about whatever you're looking to make. Okay, proofing is a money saver for many companies. This is just is an architectural piece, but a lot of times companies will want to make a very large piece out of aluminum, aircraft gated aluminum, pieces of material they're looking at $35,000, $40,000. They don't want their CNC program to be wrong, so they'll buy a large block of the urethane board, run the proofing program, make sure there's no mistakes, no errors, and they'd rather spend a couple of $1,000s perhaps on some tooling board versus buying a multi-$1,000 aluminum and then somehow in the middle making mistakes or finding errors. So this is not as highly used as I would think it would be, but it is a process that I wanted to present. Okay, custom cuts. This is pretty simple. You can see the various cuts, straight line cuts, diagonal cuts. Really the purpose of this was to make sure everybody knows this does not have a grain. It's not like wood. It's not like plywood, MDF, anything like that. So you can cut it any direction and it's still going to be a uniform density, uniform consistency. Custom bonds. I wanted to show this because it tags into an earlier slide. This is a 40-foot long piece of bonded 10-pound density. And you might think, well, what would you use something that large for? Well, if you remember the facades, this is the piece of material that we sold to the customer, who then made a mold to this configuration so that they could do layups and make these building facades. So I wanted to show size and capabilities on projects. It's I don't want to say limitless, but you can get some very large products. Step tools. This again is these are bonded pieces, and say you have an aircraft wing that might be in this shape. To save money, save time, and get it delivered, ready to cut and put on the CNC machine, we build a step tool where these blocks are staggered like this, so that once it arrives, you're not wasting all the time cutting out this center section and the time wasted just machining down to this near net shape. In some cases, you need mirror images, so we do a right side, left side. This piece was for a radome for an airplane. The radome is what's on the nose of the aircraft, protecting the radar and the electronic instruments in the nose of the aircraft. Now, I have a picture of the aircraft. It wasn't for this particular mold, but that's what we're talking about. And now, some huge stuff. This piece was a bonded block. Naturally, it didn't. We couldn't cast anything of this size, of this nature. This total piece weighed 24,000 pounds. Had to take a dedicated flatbed, oversized flatbed, to move it. Luckily, our facility is located right next to a crane rental place, so we knocked on our neighbor's door, were able to borrow a crane, and they ran it and was able to get it loaded up and out on the road for us. Another large piece is this six-sided piece. I'm not even really sure what this one's for, but again, I just wanted to show the scope and the size that is achievable with the product and bonding. For maybe some fun stuff, there's a company up in Canada called Imagination Corporation. The owner is Pat Sawatsky. He's an industry icon, in my opinion. He makes things, does things that are just unbelievable. If you ever, if this up close, the stonework around the outside edge, the gears, almost kind of steampunk-esque, but it's just an art piece in the finest sense, in my opinion. Scale of things, he made this robot, and you can see the magnitude of what it is. Again, structurally, it's steel, but it's clad in the urethane board. This might look familiar. This was a scene from Star Wars, of course, which ended up in a office like this. And burgers, fries, and a drink. If you have need any questions, inquiries, anything like that, our Precision Board site. And thanks for your time. And do you have any questions at this point?